I'm Professor Douglas Paul, a Royal Academy of Engineering Chair in Emerging Technologies at the University of Glasgow. I'm now a chartered engineer, but how did I get into engineering? Well, from a young age, I was always trying to build and engineer things, whether that was with Lego, balsa wood, boats, or aircraft models. My father was an engineering lecturer, and he had students working in companies around Scotland. So I went to visit, and after seeing many sectors, wanted to work in semiconductors. So my whole engineering career has been using micro and nanofabrication in clean rooms to develop first faster transistors, but also developing new and smaller sensors. So with colleagues in Glasgow, we demonstrated the world's first micro electrical mechanical system, or MEMS gravimeter, using a mass and a spring, all made from silicon. So unlike a Hooke's law spring, where the mass feels a larger restoring force as it moves away from the rest point, we used a geometrical anti-spring that gets softer when it gets displaced. So the MEMS gravimeters are made using the same manufacturing processes as accelerometers that set off car airbags, but the anti-spring makes it 50,000 times more sensitive. So sensitive, in fact, we can measure the gravitational force of the moon orbiting the Earth, or even of a person about half a meter away. So these MEMS gravimeters are now being used for applications in energy, carbon sequestration, and navigation. I've also developed new single photon avalanche diodes, or SPADs, that can be used for 3D imaging and LiDAR, and they can see through fog, mist, or rain many kilometers away with eye-safe laser powers illuminating the subject. And this enables vehicles to see ahead and navigate even in bad weather. Now, silicon SPADs are what do the facial recognition in your mobile phone, but the near visible wavelengths in these cameras limit the distance they can see. By adding germanium, it allows them to operate at longer wavelengths, where the atmosphere is more transparent, there's less background light from the sun, and so we get higher signal-to-noise ratios. So I would like to thank all the teachers, lecturers, and professors that have helped and inspired me to get where I am today in my career, as well as all my colleagues and collaborators who've been essential delivering the technologies I've been working on. I'm excited and really honoured to have been elected a Fellow of the Royal Academy of Engineering, and look forward to working with them to try to solve many of the challenges our society presently face, but also to try and inspire future generations to pursue rewarding careers in engineering.